Unit 4, Managing Storage Pools and Storage Pool Volumes. When you complete this unit, you can describe the purpose of storage pools, storage pool hierarchies, and storage pool volumes. You can create storage pools, move data, and design and configure storage pools based on the customer requirements. You'll also be able to manage storage pool volumes and their data. Storage pools are where the copies of your backup data will be. Your database is going to keep track of where all the files are. The actual file copies will be in storage pools. A storage pool is a collection of like media. They'll have the same device class. And we'll talk about device class here in just a few slides. Basically, you cannot have, say, a tape device class and a disk device class in the same storage pool. So your storage pool must have like media. So you would have a disk storage pool, maybe a file device class storage pool, which is actually being stored on a disk, but sequential access storage pools, where the data is stored on disk, is a device class of file. There are a multitude of supported devices. Just the number of tape libraries that are supported by Tivoli Storage Manager will give you something to read for a very, very long time. Now, one of the benefits of storage pools is you can define the next storage pool in the hierarchy and have data migrate from storage pool to storage pool. The three destination pools that are predefined are backup pool, archive pool, and space management pool. These three destination pools are of the disk device class. They should be on your fastest disk. This is where the copies of your backup data is going to be written. You want to get as much data there as fast as possible. Then, when you've created your storage hierarchy, the data would migrate from the fastest, most expensive device to the mid-range. This will then empty the destination pool for the next backup. So ideally, your top level will be large enough to hold at least 1 day's worth of backup. Then you set your migration threshold, which we'll get into in a minute, so that when it reaches a certain point, say 90% full, it kicks off migration and data moves from this pool down to the next pool you have defined. What I'm showing here is the mid-range pool is not your slowest but not your fastest, not your most expensive but not your least expensive. In this case, we're going to use a physical disk to hold the data, but we're giving it a device class of file. This is because the top level is random access storage pool. The next levels are considered sequential access storage pools. Sequential access storage pools with a disk are considered file device class. Random access storage pools on a disk have a disk device class. And then finally we have our mid-range storage pool that migrates down to, in this case, a tape pool. Tape pool is going to be a little bit slower. You're going to need to mount the tape volumes to write to them, but they're also the less expensive. So this would be the ultimate storage for your primary storage pool. In addition to primary storage pools, we have copy storage pools. Copy storage pools are backups of your primary storage pool. Why do we have copy pools? Media can go bad. You can lose copies in your primary storage pool. If you have a copy pool, you can rebuild it. You can put that copy back into the primary storage pool and rebuild it. Copy storage pools not only provide the integrity of your primary storage pools, but if you have a copy storage pool that is on removable media, like tape, you can eject these tapes and take them off-site for, say, storage. Another type of copy pool we have is called an active data pool. You'll learn a little more about versioning in Unit 6. Basically, when you set up your policy, you determine how many versions of backup data to keep. If you have, say, 3 versions, that means you're going to have 1 active version and 2 inactive versions. 1 recent version and 2 previous versions. Your active version is the most recent backup. Since the majority of the restore requests are for the most recent backup, having an active data pool on site really helps with your restore times. You won't have to sift through versioning, you'll just have the latest version. Active data pools can also be written to tape to take off-site. Now the thing with active data pools is many times that data is only valid for one day. If that file is written to the next day, that version is now the inactive version. So if you're using active data pools, you're putting them on tape to take off-site, you'll need to do this daily. One thing you can do, and we'll be doing this in a later unit, is setting up a maintenance script. We saw this in the Administration Center. The maintenance script will back up your primary storage pools to copy pools. It will do this automatically for you, and you can even set it to write to more than one place at the same time. Simultaneous write. Again, we'll get into this later in the course. Just know that you have that capability. Now, a device class is basically a name we give a device so that when we're defining our storage pools, we can point it to this specific device. By default, you have the disk device class predefined. The disk device class is for your random access storage pool. That is your destination pool, the top level pool in your hierarchy. The next pools, and same with copy storage pools, use a sequential access type. So it's going to be tape, for example, the type of tape library, or file if you're storing the files on disk. In our command we see here, we're defining a device class for example auto DLT. So the command, here's the syntax, and here's the example. Define devc, we're giving it the name AutoDLT underscore class, that's the dev class name. The dev type or dev t is DLT. And then we add some information about the drive and the library. Now, where would you find the parameters and options for the syntax for define device class? That's correct. You would issue the help define devc at your administrator's command line, or look in your administrator's reference guide. It's got all the commands, many of the different options, examples, like you'll see how to define a device class for a disk or a file or a tape, like we're showing here. Now you'll be doing this in class. You'll be defining a device class just for your database backups. You'll be defining a file device class to be in your storage pool hierarchy. Since we don't have a tape library in the class, the part of the tape will be played by file. So we will be setting up file device classes and an additional device class just for database backups. Supported devices. The IBM web page has a list of all the supported devices. There are pages and pages of tape device classes. One thing to remember, when you get your device, if you're getting an IBM device, you'll use the IBM device driver. If you get a device type manufactured by someone other than IBM, you'll be using the TSM device driver. How device classes map to storage pools. Before you can define a storage pool, you'll need to define that storage pool's device type. So you could have a device type for disk. This is going to be your high-level random access primary storage pool, your destination pool. And again, there are 3 predefined: backup pool, archive pool, and space management pool. But you could have another random access primary storage pool as a destination. Before you could define the storage pool, you would need to define the device class. Then here, our device class, we're going to use the device class of file. It's a sequential access storage pool. And then we have device class tape here at the bottom. Our data migrates from your destination pool through the storage pool hierarchy, freeing up the top level, most expensive, fastest devices to get the data from the client. Storage destination. This is an example of how to customize your storage hierarchy. On the left, we have the sales department. In the sales department, the data comes into the disk pool, the primary storage pool at the top level or destination pool, and then is migrated to tape. However, the accounting department wants to have a mid-level, a file device class. They want the data migrated from the primary destination pool to the next storage pool in the hierarchy, in this case, a file device class. File device class means the data is stored on disk, but it's sequential access. Then it moves to the tape pool. For LAN-based backups, this is as opposed to a storage area network backup. With LAN-based backups, your random access is the predefined disk device class used with all disk devices. So random access storage pool must be disk. Sequential access storage pool can be tape, file, optical, any other type of supported device. Once you've defined your device class, you can define storage pools. The command is define storage pool, or DEF space STG, the name of the pool and the name of the device class. Now, depending on the device class, you might have additional parameters. You'll be doing this in the lab, but you could also go to your administrative command line and type help define storage pool and see all the different options you can use. Another way of doing this is with the Administration Center, using the Storage Devices tab and then selecting View Storage Pools. From there, select Create a Storage Pool. Other commands you can use with storage pools: you can update an existing storage pool and change some of the options. You can query your storage pools, and you can also query occupancy, or Q space OCC, and the node name. This is going to tell you all of the information about client file spaces for each node. Why would you update a storage pool? Well, let's say you have a storage pool and you've decided you want that storage pool to be an active data pool. You can change an existing storage pool, or you're creating a storage pool hierarchy. You take your existing storage pool and you can provide the information for the next storage pool in the chain. Storage pool volumes. Storage pool volumes is the actual location for your stored data. You have the three predefined storage pools: backup pool, archive pool, space management pool. But they don't have any volumes yet. Before you can back up data, you must define volumes. On a disk device class, this would be a random access primary storage pool. You're going to create directories. You're going to have physical locations on the disk that will serve as your volumes. For a tape device class, each tape will be a volume. So when we're talking about tape, each volume is actually one tape. If you're talking about a disk or file device class, you will determine the size and location of that volume. You'll be using both command line and the Administration Center to define volumes. Here's an example of defining a volume for a disk. So this would be our top level. This is our destination pool. Define volume, the name of the storage pool, the name of the volume, and the format size is the size. Our example: define a volume for backup pool. We're going to, in this case, we're using AIX, and we're going to put the volume in opt tivoli tsm data. This is a file that we have created, that we put into the TSM subdirectory. Then we have our volume name, volume 6. Format size equals 200. Unless you specify otherwise, it's going to be in megabytes. So here's an example for Windows. We're going to define a volume for archive pool. Yes, we have backup pool and archive pool predefined, but we need to use them, so we need volumes. In this case, we're defining the volume for archive pool. We're going to use a directory we have created here on the E drive, TSM data, and the volume. Occasionally, you'll need to move data. We can do this with the move data command. You can move files from one volume to another volume in the same storage pool, or you can move them from storage pool to storage pool. If you're going to move your node data from storage pool to storage pool, use the move node data command. The example is here. Move node data, the name of the node, from storage pool and the name of your source storage pool to storage pool and the name of your target storage pool. This way you have just moved all of your data for one node from one storage pool to another storage pool. The command above it, move data, volume name, storage pool name, is you're changing volumes. Now, a compelling reason to do this is if you have, say, a damaged sector on your volume and you want to move the good data to another volume. You use move data, then once the valid data has been removed from that volume, you can change the status of that volume from read-write to destroyed and move it out of the library and replace it. Node replication is a new feature that lets you basically store a client node's data on another server. This is going to use what's called server-to-server communications, and we don't go into it in this class other than to let you know that it is available. It's a more advanced feature. It's a way of ensuring client data is safe. It's for disaster recovery purposes. Ideally, you would be storing the node data on a server in a different location. Before you can delete a storage pool, you have to make sure that all the volumes in the storage pool are empty and deleted. So the commands you would use to check out your storage pools is you're going to query the storage pool with format equals detail. Find the name of the volume. Then you're going to query that volume, and then query content for that volume. Once you've removed or moved the data from your volumes, you can delete the volume and say discard data equals yes, because in this case, let's say you've removed the good data with the move data command. Anything left on this volume you want to discard. Then you could also delete the storage pool if you needed to. You can't delete a storage pool that has volumes with data. Some of our processes allow you to read and write to volumes simultaneously. Client sessions that can concurrently read and write to file volumes are your backup, restore, archive, and retrieve. Server processes that can concurrently read to file volumes, your backup, your database, backup storage pools, copy active data, etc. What's on the list. This means that you are reading on one while you're writing on the other. Concurrent access. It speeds up the time. Overflow location for storage pool media. Hopefully you won't need this. Hopefully your tape library has enough slots for all of your tape cartridges. If your tape library becomes full, you'll need to check out some volumes so that you can add more empties. In this case, for the volumes that are needing to be ejected and stored outside the library, you can update your storage pool and list an overflow location so that TSM then knows that certain volumes are no longer in the library, but in this case they're in locker number 24.